Okay, sorry everybody. So we now have Scott Olsen speaking on the quest to uncover the golden balance. Thank you, Scott. Over to you.
Okay. Greetings, and thank you, Grenville and Barbara, for all your assistance. This is the quest to uncover the golden balance, the principle of equilibrium underlying nature and the cosmos. I want to mention a couple people to begin with were very important in this. David Bohm at Birkbeck, while I was in the philosophy department from 75 to 77. I was one of his students, only 3 students we'd meet in his office, class. And very important what he says here, the essential features of quantum interconnectedness are that the whole universe is in some way enfolded in everything, and that each thing is enfolded in the whole. And it's really holographic, it's fractal, and of course John Hasted, Basil Hiley, and David Bohm, very important in the process. So I'm going to kind of lay out what I'm doing here ahead of time. From the Bohm perspective, the super implicate order I'm going to try to demonstrate is the one and the indefinite dyad, and their pre-number ontological principles. For Bohm, this would be the basis of the whole movement. These are the driving force of nature of the cosmos. Then the implicate order is the golden mean number system and the root ratios, for example, root 2, square root of 3, and 5. And then the explicate order is expressed in the flora, fauna, and the cosmos via Fibonacci and Lucas numbers, which are the golden mean number systems, whole number expression in nature, for example, in phyllotaxis, leaf arrangement, growth. Everything pushes out and spins at the same time, orbit spins, turbulence, phase shifts, periodic table of elements, and of course the ideal divergence angle, or the genetic angle, of 137.5 degrees. I've done a lot of research, not only in Egypt, but around the world, trying to figure out what's going on from ancient cultures, much of it from the ancient wisdoms, basically Plato and Pythagoras that I'm following, and their initiations into the Egyptian and the Eleusinian mysteries. And the golden section is not a product of mathematical imagination, but the natural principle of the laws of equilibrium, according to Schwaller de Lubitsch and the Temple of Man. Incredible mathematics that was going on in ancient Egypt. So here we have my good friend Garnet Ord with Laurent Pal and Mohammed Al-Nashi. They are the founders of fractal space-time in physics. And here they're at Mohammed's home in Kabul. Mohammed called them the 3 musketeers. And it's Mohammed who, with his E-infinity theory, using Cantorian space-time, which is really to me, the essential form of physics. In 2006, I wrote The Golden Section, Nature's Greatest Secret, after having an experience with ayahuasca in the Peruvian rainforest, where I remained awake for 19 days straight, and then within a year I wrote this, which is now in 9 languages. Then I helped Lexi Stackhoff with the Mathematics of Harmony and the Golden Non-Euclidean Geometry, and in 2010 I was with him in Odessa, Ukraine at the International Congress of Mathematics of Harmony. In 2012, when I was in Alexandria, I was able to get the Golden Section back into the Library of Alexandria, where it always should have been. Here's Garnet, Mohammed, and myself at Mohammed's home in Alexandria, Egypt, back in 2012. And I'm going to kind of lay out things right off the bat. The golden key is up in the top here. This is the uppercase Greek letter phi, and its inverse 1/5, which we call phi, and sometimes we use a lowercase letter phi to
recording in progress.
I guess recording is on now. And I won't start over because, lordy. Start it over. Out with it. At least I can show the slides when it's recorded. So again, it's the quest to uncover the golden balance, the principle of equilibrium underlying nature in the cosmos. David Bohm was really important in my background, the essential features of quantum interconnectedness are that the whole universe is in some way enfolded in everything, and that each thing is enfolded in the whole. I was back in 75 to 77. I was a student of his in his office. Hasted was important. Basil Hiley was important. And the superimplicate order, following Bohm's thinking, the one and indefinite dyad are pre-number ontological principles. The implicate order is the golden being number system in the root ratios root 2, root 3, and root 5. The explicate order is expressed in the flora, fauna, and the cosmos via Fibonacci and Lucas numbers through phyllotaxis, leaf arrangement, growth, orbit spins, turbulence, and phase shifts, periodic table of elements of the ideal divergence angle or genetic angle of 137.5 degrees. Egypt has also been extremely important, and you see here Schwaller Delugich. The golden section is not a product of mathematical imagination, but the natural principle of the laws of equilibrium. If you want to see what it looks like from the top of the pyramid, this is what it is right here. Garnet ore was really important with Muhammad al-Nashi, and those two, along with Laurent Natal, Muhammad referred to them as the Three Musketeers. They are the founders of fractal spacetime in physics. And then in 2010, I was at the International Congress of Mathematics of Harmony with Alexei Stakov. I helped him with his books, The Mathematics of Harmony and the Golden Non-Euclidean Geometry. In 2006, I published The Golden Section, Nature's Greatest Secret, now in 9 languages. And that's after I had an ayahuasca experience in 2005, in which I was shown both inside and outside how the golden section works throughout nature. In 2012, I was able to give it back into the Library of Alexandria. Here at Garnet Ord, Muhammad and I are in Muhammad's home in Alexandria, Egypt, back in 2012. Here's the key to the whole thing, the golden key. Big phi, it's Greek letter phi, and it's reciprocal, 1 over phi, and unity or 1. This is the driving force of nature itself that gets expressed in Fibonacci numbers and Lucas numbers. I've earmarked here 5, 8, 13 microtubules. Penrose and Hameroff probably, in my estimation, have the closest to the correct model of consciousness going on and the resonance and the vibrations of the microtubules. Number 7 here we'll come back to later in terms of the Lucas numbers. They are magnificent, and these, the greater and lesser, I'm going to call these, you're going to see as we go on, along with 1, that is what creates all of the numbered system that we have, the integers in nature. We recognize with one law in the universe, the law of harmony and perfect equilibrium, that's coming from the Nirmanakaya, KH and the Mahatma letters. This is a driving force throughout my life in search of this perfect equilibrium, and I think we found it, and that's what this talk is about. So back in 1983, I did my dissertation at the University of Florida, the Pythagorean Plato and the Golden Section, the study of it in that type of inference. And I was basically following the work of Charles Sanders Peirce, who had rediscovered in the works of Plato and in Aristotle that that's the method that Plato was using. He was the midwife presenting the problems to the members of the Academy and to the readers of his books, and it's with abduction. It's the only logical operation that introduces new ideas. Kuhn was very important with the structure of scientific revolutions, and Einstein abducted relativity theory in the face of the anomalies of black body radiation, photoelectric effect, and specific heats. I put this image in here because this is an incredible book that I think by Kieran and Fox, I Am an Art of Infinity, the Spiritual Journey of Albert Einstein. Aristotle in Metaphysics tells us, since the forms are the causes of all other things, he thought their elements, their principles, were the elements of all things. As matter, the great and small were principles, as substance the one. From the great and small, by participation in the one, come the forms, the numbers. The great mystery was, what were the greater and lesser of the indefinite dyad? And sometimes you have to look at the oral tradition to try to figure this out, but there are fragments that we can find. And once this thing is solved, many of the puzzles, conundrums of Plato's dialogues become extremely clear. It solves everything. Plato in the Timaeus maintains that there is a bond of nature. Two things cannot be rightly put together without a third. And the fairest bond, the most complete fusion of itself with things, is proportion, analogia, and it's best adapted to effect such a union. He's talking about continuous geometric proportion there. So an anomaly occurs in the Republic, Plato's divided line. He presents a little puzzle. Take a line and cut it unevenly. Why a line and not numbers? And essentially it's going to be because they are irrational numbers. They're not really numbers according to Schwaller-Lubitsch. They're numbering, and they're in the implicate order. But so when you do the golden cut, now you can do it up here, or you could do it down a little bit lower. In fact, when I do the divided line, you'll see I kind of flip this thing over. Actually, if a person were standing here on the top of their head here, their feet at the bottom, this would be roughly the navel. Over the 32 years at the College of Central Florida, I would measure students again and again. Most would be roughly 5 units tall, 3 from the floor to the navel, 2 from the navel to the top of the head, but all kind of Fibonacci sequences, 3 sums, but also Lucas as well. So the ancient Egyptians referred to this as the primordial scission. So you start with 1, the magnitude, and then you cut it in such a way that the whole is going to be the longer as the longer to the shorter. And what results is you get 1/5, which again is little v, that's the lesser golden ratio, 0.61803339, and then little baby phi squared, 0.3819. However, here's the key to figuring this out. What you do is you make the longer segment 1, that forces the whole line to immediately show itself to be big phi, 1.61803339, and the shorter segment is little baby phi, and now you have your 1 and your greater and your lesser, as I'm going to be demonstrating. And so you have your whole line is to the longer segment, as the longer is to the shorter. We set it up over here, and so you have big phi is to 1, is as 1 is to little phi, and because these are identical, what we'll see in the divided line, these collapse, helping solve the conundrums in the divided line. In 2002, I wrote The Indefinite Dyad in the Golden Section, uncovering Plato's second principle, and essentially, which was something new, a novel hypothesis, making, and I was using lowercase here, I hadn't really changed to the script, but so big phi is the golden ratio, the greater golden ratio, and 1/5, little baby phi, is the 0.618, and then you have these various relations. You multiply them together, you get 1, you subtract them, you get 1, you take their square root, you get 1, etc. And the fact that the ratio of the greater to the lesser is phi squared, not phi, is crucial to what I'm saying. So Kenneth Sayre presented a challenge to anyone who wanted to propose a golden section as a solution to Plato's divided line. He says it's barely possible that Plato had the golden section or golden rectangle in mind when he constructed the divided line. The commentator convinced of this would have the formidable job of making sense of this extended quantity. We see here A is to B equals C is to D equals A plus B is to C plus D equals C plus D is to A plus B plus C plus D. He wrote this in his Plato's Ontology, Riddle Resolved. Actually, Sayre was brilliant. I've gone back to him, and he realized that much of this is already in the dialogues, and so he deserves some credit. And here's, when you take the divided line and you cut it again into 2 parts, you get 4 segments, and down here in Ecclesia, where the false conjectures, the image shadows on the wall, let's say, are reflected. So A is to B, the ordinary objects, as C, D, and Noia, the mathematicals are to the forms, D, as A plus B, the sensible lower world, is to C plus D, which is the intelligible world of Plato, as the whole friggin' thing is to the greater C plus D, and then A plus B down here. Now, if you take the compass, put your compass point here, pencil lead up there, arc down, here's a simple solution to Plato's divided line. I guess first I should say, if you take this whole length here, and then you take the longer segment here, that's in golden ratio. If you take the longer segment and compare it to this shorter segment, golden ratio. If you take the shorter segment and little baby bear segment here, golden ratio throughout. So the whole is to the upper intelligible realm as the intelligible is to the sensible realm below, as the world of forms are to the mathematicals in the same ratio as the mathematicals are to the lower ecospheric level. And here's Plato's ontology, epistemology. It's also his aesthetics. It's also his ethics as well, when we really begin to figure this out. So here we have the forms and mathematicals, ordinary objects and distorted copies below. Illumination occurs up here when one rings the bell and goes up and figures this out, goes into union with it. Here's the noetic level of direct intuition with the forms. Dianoia, mathematical reasoning. Mathematicals are like the forms, but there are many of them, because they're going to be infused as an implicate order into the ordinary objects of pisces or belief down here, and then the distorted copies are a case of false conjecture. Although if you make it, you get up here, you bring it back down, you then beautify the world with your artwork, etc., and you bring heaven back onto earth as it really should be. And so basically here you see at the intermediate level here, the root ratios, the greater and the lesser, expressed particularly through the dodecahedron. These platonic solids should probably be down here in the explicate order, but I just wanted to associate them with their particular solids. And then you see what happens here. Here you've got your Fibonacci numbers, you've got the flora and fauna. These collapse, and so you have your greater is to 1 as 1 is to the lesser. That's what happens when one goes into a higher state of consciousness, figures it out. Plato was a genius. Initiates into the Eleusinian and Egyptian mysteries were forbidden to reveal the truth of the golden section. That was the key, as Madame Blavatsky points out in The Secret Doctrine. What was revealed in initiation were the mysteries of proportion. But here's what Plato does. He secretly embeds it in his dialogues for those who can abduct the solution. And in fact, he begins at the 1, and then you're going to see 2, 4, 8 in the divisions in the sun simile. Divided line goes to 4, 8, and that's exactly what he's doing. By the way, I should have piped up when Barbara did her presentation on Zen Buddhism, the emptiness in terms of the Cantorian space-time of Al-Nashi. Here we have the pre-quantum particle, we have the pre-quantum wave, and we also have the zero Cantorian zero set, and here we have the empty set. And here's Muhammad, we're in Egypt, as you see, and here's our book, Grand Unification of the Sciences, Arts, and Consciousness. And a lot of people don't realize how deeply Muhammad al-Nashi went. Ilya Prigogine, I have the letter, nominated him for the Nobel Prize in Physics. In fact, he was nominated twice. Muhammad recognized that the golden mean number system, of which the one and indefinite dyad are the core, is the lingua franca, or language of nature in the cosmos. And he found great success in his infinity theory, using the Cantorian space-time, because he's able to merge the continuum with discreteness in the process. Garnet Ord is the one on your boat trip who can explain any of the physics. I'm the philosopher, those guys are the physicists. In 2004, the 2004 Nobel laureate Gerd Binning nominated Muhammad for the King Faisal Award. Binning said this second only to the Nobel Prize that he received, because Binning received it as well. It was as great a award as the Nobel Prize. Here's what he writes. Al-Nashi was able to find an exact value for the coupling constant at which all the forces melt into one, the superforce. His theory not only predicts with astonishing precision the mass spectrum of all elementary particles of the Standard Model, including the quarks, which, by the way, thought not to be possible without additional input, he also was able to determine directly a number of the fundamental constants. In my eyes, Al-Nashi's theory constitutes a grand design of a deeper understanding of nature. That's pretty. So here we have the one and indefinite dyad. Here, with Cantorian space-time, the pre-quantum particle, phi squared, the wave, Einstein space-time. Of course, you take the inverse over here, phi cubed, 4.236. That's the Hausdorff fractal dimension of space-time. Unruh temperature. These are all phase shifts. It's all according to the golden mean number system. And this is the biggie. Entanglement occurs at v to the fifth power, little baby v to the fifth. And as Roger Penrose says, the reduction of the wave packet, it is non-local. And non-locality occurs at entanglement. And here's the Barbero-Immersi parameter over at v to the sixth power. And of course, when you make ratios out of the Fibonacci numbers, we have the Fibonacci's down below here, and then you take like 1 is to 1 is 1, 2 is to 1, 2. Very quickly, 3 is to 1.5, you begin to approach the golden mean, as some of you have been calling it, the kind of the sink, the golden sink that everything, the golden attractor that everything is falling into. And so you see how it asymptotically goes above and below, a little bit more, a little bit less, and then into it. I earmarked 5813 again because, well, we're not going to talk about microtubules actually, but there are 13 filaments in a microtubule, 8 spiraling one way, 5 spiraling the other, and at the tips of the microtubules are clathorins. Clathorins are buckyballs. If you take the dimensions there, you got 5 cubed is to 1 dimensions. And Lucas numbers, same thing, and they collapse into the golden section in the limit. And I've earmarked 3, 4, 7, 11, 18. Better remember this. So 7 becomes the geometric mean, approximately 4 and 11. 4 times 11 is 44, but 7 is the square root of 49, so you have to add 5. In the next step, you're going to subtract 5, add 5, subtract 5, all the way to infinity. So, the source, God, the source creates the integers, fair enough. All else is the work of man. But how does the divine do this? Through the golden ratios. So, big phi to the fourth power and little phi to the fourth power. In this case, you add them together all the way to infinity. And you'll see it's 0.999999999, and this is how you generate the number 7. With the Lucas numbers, you generate that series by alternately adding and subtracting the powers, the golden powers of the greater and the lesser big phi and little phi. Plato really reveals this for people who really have the eye to see and the ear to hear. In the Tres Modatus, the 3 monads, in the Philebus. And he lists these as truth and beauty. So at the summit of the cave, you have the one, which is the good in the dialogues, and then you have truth, which we're going to call little baby phi, and beauty, big phi. You could reverse these. They're the inverse of each other, but they are what are controlling. The reason we're picking truth here is because in science, typically you're going to cut things, or you look at the smaller piece, and when you're looking at aesthetics, you're oftentimes looking at the greater relative to unity, the measurements. So in the Philebus, Plato has Socrates discuss the mixing of forms in the preparation of an incorporeal ordered system for the control of the corporeal subject in which the soul dwells. He says, we now stand upon the threshold of the good, of the one, up at the summit, and of that habitation where all that is life here to resides. What shall we regard as the most valuable thing? Well, any compound that does not have measure or proportion is a ruin. If we cannot hunt down the good or the one under a single form, let's secure it by a conjunction of 3, beauty, proportion, and truth. So proportion, the one, is acting as the mean, the geometric mean between beauty and truth, big phi and little phi. And then regarding these 3 as one, let us assert that that may most properly be held to determine the qualities of the mixture. And because that is good, the mixture itself has to become so. So again, Plato is cryptically giving away the farm, literally, for the intuitive, resonant reader. Everything's vibration, everything is resonance, by the way. That's why the DNA, the structure of the human body, everything is constructed. It's really kind of like ready to rock and roll, like stem cells. But anyway, so the symmetry monad acts as a geometric mean between the greater and the lesser. So in the statesman, here's again where he's giving it away. It says it is in this way, when they preserve the standard of the mean. So I put in brackets here the one, that all their works are good. The greater, big phi, and the lesser, little phi, are to be measured in relation to one another. When you do that, that's when you're measuring them as their opposites, and it's phi squared. However, they also need to be measured with the establishment of the mean. So when you measure them as their opposites, you're measuring them for number, length, depth, breadth, thickness, etc. as opposites. But when you measure them in relation to the, and listen carefully, the moderate, the fitting, the opportune, the needful, and all the other standards that are situated in the mean between the extremes, in other words, between big phi and little phi, the greater and the lesser. So here is the golden balance or principle of equilibrium. So Lance Harding uncovered the following significant relationship in the Golden Series, where AM here represents the arithmetic mean, GM is the geometric mean, so you have a couple geometric means going on here, and then the harmonic mean is in red here. And so this is a portion of the Golden Series. We have one, the greater and the lesser. Now, remember, the Golden Series is perfectly additive and perfectly multiplicative, meaning that if you add little phi and 1, it gives you big phi, 1.618. If you add 1 and phi, you get phi squared, 2.618, etc., onto infinity. Okay, I think that's good. Oh, Lance got his dissertation there back when the king was the prince. And Lance, who really now that Nasha has passed and John Michel's no longer with us, he really is probably the genius in terms of metrology. And he wrote the ancient Greek canon of human proportion in the Vitruvian man. By the way, the most ancient, and I got it in some slides that not included in the presentation, but the ancient Egyptians were using the Lucas numbers for the canons of proportion in the earliest dynasties. And in the 19th dynasty, they shift to Fibonacci numbers. But so they already, in Plato, it's clear. Darcy Wentworth Thompson is also a Greek scholar who, he and Taylor pointed out the same things I'm talking about. They would use side and diagonal numbers to approach it in the limit. The ancient Egyptians are already doing it. The mathematics of the ancient Egyptians needs to be studied. And Schwaller de Lubitsch in the Temple of Man, I'm going to tell you right now, is an absolute genius. So Adam Tetlow, while working together with John Martineau on Tetlow's wooden books, the wooden book series is what my golden section book is. In this one, the diagram, harmonic geometry is wonderful. When I gave, well, keep going here. Adam Tetlow made the following observation. And you'll see here, he's got little baby phi squared as a geometric mean between phi cubed and phi. Then he's got the harmonic mean here, a big phi between 1 and phi cubed. And he also has the arithmetic mean here, phi being the arithmetic mean between little phi and phi squared. Now, Adam wanted to know, as any other mathematician, to the knowledge of any of us geometers, and we really discussed this and tried to find anybody who figured this stuff out. And I had to let him know that in my future book, which hasn't been published, Divine Proportion, the Geometric Perfection of the Universe, I already had the work of Lance Hardy. And so Lance, working on Corbussier's work, came up with this and figured this stuff out. And I had to tell Adam this, but it's interesting. When Adam did this and showed it to me, I remembered, and I knew this before because there are other formulas that Lance had shown me, but I showed you the most significant one he had. These things can move back and forth. So this structure remains the same all the way up and all the way down. You grow bigger like Alice does, and you go smaller like Alice does through the looking glass. And the structure remains the same throughout nature. So through this collaborative effort, it led to the discovery of what I have deemed the underlying paradigmatic structure or golden balance of nature and the cosmos. Namely, the one acts simultaneously as the arithmetic, geometric, and harmonic means of the greater and lesser and their squared powers. That fivesome. And they're enfolded as the golden mean number system, as the implicate order into the substructure, the explicate order of all existence. As above, so below, and as below, so above. But that always required the third factor, the geometric mean that bonds the above and below. Plato realized that, did his best to depict it for readers in the future who would be able to see it in his dialogues. But this is the key to nature right here before your eyes. Now, not only does this structure exist with one, as I was saying, but this can flow along and you'll see here we have p squared, little baby p squared, as the geometric, harmonic, and arithmetic mean, but it can shift. So here v becomes the mean. Here is the paradigmatic symmetry there with 1. Phi becomes the mean in all three cases, pi squared, etc. All the way up, all the way down, it remains the same. Furthermore, we found that it's clear that the three means also flow along with our Fibonacci numbers, which is nature's expression of these things. And always the arithmetic mean, because it's the nature of the beast. When you add, for example, here 1 and 3, and you get 4 divided by 2, 2 is the arithmetic mean. It always works exactly. But because we're using integers now, not the beauty of the golden mean number system, we have to use corrections. So if we're looking at the arithmetic, at the harmonic mean, well, let's use geometric mean first. So 1 times 3 is 3, but 2 is going to be the geometric mean of 4. So we must add 1. And so the result is 2 when we take the square root of the product itself. Oops. And for the harmonic mean, we double 1 times 5, which is going to give us 10. But we're going to have to add 2 because we're going to divide by 6. And so what we're going to find now is we're going to alternately, for harmonic means, add 2, subtract 2, add 2, subtract 2, just like with the geometric mean, we'll add 1 and subtract 1, so we come to the next one. So for the geometric mean, 2 times 5 is 10, but 3 is the square root of 9, so we have to subtract 1. For the harmonic mean, we double 2 times 8, but we're going to have to subtract 2 so that we can get the 30 divided by 10, which gives us 3. So again, with the geometric mean, we're going to add 1. 3 times 8 is 24, but 5 is obviously the square root of 25. Here we double 2 times 8, which is 32, but we've got to subtract 2, which gives us 30 over 10, which gives us 3. Oh, I'm sorry. times 13 is 78, but we've got to add 2. We get 80. 80 divided by 16 is 5. Here, 5 times 13 is 65, but we have to subtract 1 to get 64. Square root of 64 is 8. With the harmonic mean, doubling 5 times 21, we're going to have to subtract the 2, and so we're going to get easy. So 2 times, so 5 times 21 times doubling is 210. So we're going to have to subtract 2, giving us 208. 208 divided by 26 is going to give us 8. So then with the geometric mean, 8 times 21 is 168, but we need 169, so we add 1, square root 13. With the harmonic mean, we've got 2 times, we double the 8 times 34 to get 544, but we need to add 2 to get 546. 546 divided by 42 is 13. Now it's interesting, the same thing happens with the harmonic mean. Most people know that you have to add and subtract 5, but what's going to be interesting is we're going to see we double that for the harmonic mean, and we're constantly, Lucas series, constantly adding and subtracting 10. So here, for the geometric mean, 1 times 4 is 4, but really 3 is the square root of 9, so we have to add 5. The root of that, of course, is 3. Oops. Back. Sorry, trying to brush it quickly. That's weird. Oh, we're okay to that way. Okay, so for the harmonic mean, we double 1 times 7 is 14, but we need to add 10 to get 24. 24 divided by 8 is going to be 3. Come to the next one. 3 times 7 is 21, but we need to subtract 5 because 4 is the square root of 16. We work out the rest. Then we, for the harmonic mean, we double 3 times 11, we get 66. We need to subtract 10 to get 56. Divided by 14 is 4. Coming to the next one, I'm just going to work through these so you see definitely this is exactly how it works. So 4 times 11 is 44, but we need to add 5 to get 49 because the square root of 49 is 7. Then for the harmonic mean, we double 7 times, we double 4 times 8, so we get 144. We have to add 10 to get 154. 154 divided by 22 is 7. So then we come to this baby, and we are here with 11 as a geometric mean. 7 times 18 is 126. 126 minus 5 gives us our 121. Square root of 121 is 11. For the harmonic mean, we double 7 times 29, we get 406. 406 minus 10 is 396. 396 divided by 36 is 11. And then finally we come to 18 as the mean. So for the geometric mean, 11 times 29 gives us 319. We need to add 5 to get 324. Square root of 324 is going to be 18. For the harmonic mean, we double 11 times 47, which gives us 1034. But we need to add 10 to get 1044. 1044 divided by 58 is 18. Now, we go a step further. Any additive series asymptotically merges into the golden mean in the limit. The greater attractor is the golden mean, the greater. If we divide the larger number by the smaller number, same thing happens. We move into the lesser golden mean, little baby v, 0.618. Working with my tech guy here, Aaron Schmidt, who's been extremely helpful, actually sitting here beside me right now. We discovered, kind of the hard way initially, by doing different additive series. And by the way, the Fibonacci and Lucas numbers are approximately geometric, whereas the golden series, each new number is the former number multiplied times big phi. It's approximately that case with Fibonacci and Lucas. Even though they're perfectly additive like the golden series, they're only approximately perfectly multiplicative. But here's what we found. Once you figure out the correction for the geometric mean, and always the arithmetic mean will be, because of the nature of starting with the numbers you do, it's always going to be perfect. You add those together and divide by 2, you'll always have your arithmetic mean. But what we found is, whatever the geometric mean corrective is, the harmonic mean will always be double that, for all numbers. And so we found a further generalization for calculating the correction for the means in any additive series. So for any series with the seeds x and y, the correction for the geometric mean is y squared minus x squared plus x times y. The correction for the harmonic mean is always the double of this correction. The corrections again alternate, just as they do with Fibonacci and Lucas, positive and negative for each term. And so the golden balance, or principle of equilibrium, is the key, is the paradigmatic symmetry, is in fact the golden balance. The one acts simultaneously as the arithmetic, geometric, and harmonic means of the greater and lesser and their squared powers. And using David Bohm's language, they're enfolded into the explicate order. The golden mean number system is enfolded into the substructure of all existence. And again, as below, as above, so below, and as below, so above. And again, it's that mean between the extremes that solves it all. And so this is what I want to leave you with, is the golden balance of nature. And a lot of things are going to come out of this. We are firmly convinced. And here's my email address and a couple of my websites. The Mysteries of the Amazon, Visionary Artwork with Pablo Marengo and his students. When I go into the rainforest and work with the shamans and go into these inner states of consciousness, not for everybody, by the way, but we did a huge exhibit of their artwork at the Appleton Museum here. It would be nice to share with you sometime. Now I'm going to get my image back.
Oh, that's great, Scott. Thank you very much. We've actually got a few minutes for questions, so
Absolutely.
anybody got questions or observations? We all know the golden ratio, but it gives a lot of food for thought, though.
No one has a question about the golden balance, okay?
So, what's the connection with the pyramids?
Well, the pyramids are based upon the golden section in the sense that actually, do I have that in here? Let me click through a few things here. I think I've got the image. Maybe I don't. No, it's not in this. So the height of the Great Pyramid turns out to be the square root of the golden section. The apothem turns out to be big phi, 1.618, and the distance from the middle of the pyramid to the edge of the pyramid is 1, is unity. So they built in this sequence of using the golden numbers, and unfortunately I didn't have that particular slide in there. And this, for anyone who wonders about how Plato would do this stuff, maybe I can just say that along these lines. The beginning of the Timaeus is 1, 2, 3. But where is the fourth, my dear Timaeus? We all know about the missing individual who's not there and got sick. However, 1 was always the equilateral triangle where all sides are 1. And you find this in Speusippus on Pythagoreanism, but it's also in Plato. You just have to work it out. The 2 is the root 2, which is for 3 of the Platonic solids, for the cube, you'll have your square root of 2. And for 3 of the Platonic solids, the tetrahedron, octahedron, and icosahedron, the faces are going to be this root 3. And these are what he gives us to construct everything. But this is conspicuous by its absence. And so I can take a second to... So then what he says is these then we assume to be the original elements of these constructions, but the principles which are prior to these, God only knows, and those who are a friend of God. Anyone who can point out a more beautiful form than ours for the construction of these bodies shall carry off the palm. He who disproves what we're saying and shows what we're mistaken, that we're mistaken, may claim a friendly victory. Hint, hint, hint. So Plato puts the puzzles in there, the anomalies, expects us to abduct. But back to your question about the pyramids. So the pyramids are encoding the mysteries of the golden number section, or the golden number series.
Wow. Thanks for that, Scott. Well, sorry to cut you off.
We have to go. Is there somebody else?
I was just about to say, we're coming to the end of the time.
Yeah.
So, thank you, Scott. Sorry we've lose a few minutes, but appreciate it.
One last comment. On the boat ride, if there are any questions, Garnet or can take my place. He'll be happy, particularly about anything that El-Nashi had to do with E-infinity theory, and also on ResearchGate, when 0 is equal to 1. I would recommend for those interested in this to take a look at that paper that El-Nashi and I did. Thank you very much for having me.